Okay, so the IcePick Energy Zone Mapping Tool was developed for the Eastern Interconnection States Planning Council. And that's an organization that was originally funded by the Department of Energy concerning the Eastern Connection. So the map on the upper right of this slide, the blue area is the Eastern Interconnection. It includes the majority of the eastern United States, east of the Rockies, as well as several Canadian provinces. The work itself, the three national labs listed here on the slide provided technical expertise to the organization, and that included Argonne National Laboratory, Oak Ridge National Laboratory, and the National Renewable Energy Laboratory. The IcePick itself is comprised of public utility commissions, governor's offices, state energy offices, and other key government agencies and representatives. Really energy planners for the Eastern Interconnection, and the Department of Energy Office of Electricity Delivery and Energy Reliability originally funded it under the American Recovery and Reinvestment Act, and since that period ended, DOE has been continuing to fund the maintenance and hosting of the tool, as well as some interesting enhancements that we're working on. So it's a publicly available tool. At the top right is the home page, and I'll provide the URL on the last slide, or if you want to search for the name, you can find it pretty easily with Google. It has a large data library, so the data are mainly geographic information system layers, which are map layers that can be overlaid. Then we have models, which allow you to model the suitability of different locations for different types of energy technologies, and a whole variety of reports on many different topics that you can run for your area of interest. And then there's a policy database that provides a lot of background on incentives and policies and regulations related to all these different clean energy resource categories that are in the lower right there. Those are pretty comprehensive, as you can see, with most of the modern ways of generating power. The tool is really designed primarily for IcePick members and for others that need to do energy planning. So that would include electric utilities and grid operators, non-governmental organizations, whether they be energy related or environmental or other categories, energy industry, regulators, energy researchers at universities, etc. And we've had quite a good response from really all of these different stakeholder communities. The registration stands over 1,100 users. Folks have registered to use the tool. So just to be clear, the purpose of registering is partly for us to get some sense of who's using the tool and to give us a way to contact you with updates and newsletters and things like that. But it's also to save your information primarily in the tool. So when you do work in it and come back, then you can continue from where you left off instead of having to start over. So I wanted to keep the introduction very brief today, so that's it. And I'll spend the rest of the time demonstrating the tool. But before I do that, here's the URL for the website at the first link there. At any time you can email icePickTools@anl.gov, and we monitor that. So we'll respond to questions or any issues you're having with the website, etc. We're planning the next webinar to be on March 26th, where we're going to show some of the new routing tools for corridors that we're developing, as well as the existing tools that have been in the tool for quite a while. And then any of the webinars and other announcements, news items are on the home page, so that's a good place to check for any future webinars or other information like that. And actively. And so I want to point out that on the home page here we have this help menu, and not only do we have sort of a hard copy help manual, and it'd be kind of tedious to read that, although it's fairly concise, but we have a whole series of videos. So if you wanted to, run a model there's about a 2 or 3 minute video on it that'll really step you through that. It might not be obvious when you first hit the website, but we don't think it'll take you long to see how that works. And that video is right there for you to learn that. And then other aspects of the tool, like just browsing the map library or running reports, etc. We've got videos on all the major features of the website. One other thing while I'm on the home page here is to point out the Policies and Regulations database. You don't need to register for the tool to search that database, and here's the page for that. So you can give different filters, like maybe what state you're in. If you do choose a state, then there's state summaries that will be included in the results that can be informative. And maybe you're interested in a particular type of energy technology, so you can look over here. Today we'll be really focused on natural gas as our primary topic, so if I choose that, natural gas, and in fact let's look at Pennsylvania. A lot happening there. Okay, so here's 30 policies related to natural gas in Pennsylvania. And that can be everything from a climate action plan to particular regulations, like here's one on air quality. And you can click these links and get quite a bit more information about those policies, including a link to the policy itself. That would be here. All right. Any of these pages has a button launch tool. So once you hit that, you'll get a display like this. This is pretty much the way it looks when it begins, and it's pretty simple. It doesn't have a lot of information on the map. So typically the way you would start would be to click the library. So I'm going to be giving just kind of a brief mention of how I'm using the tool as I work, but again, those videos are there, and it's fairly straightforward to run once you see the main dialogues and how they work. And then I'm going to try to hone down into some real analysis of natural gas in the topic. So each one of these columns can be sorted by just clicking on it, or there's this drop-down arrow and you can choose it from the menu. But there's also a filter. So if I just try a simple keyword like gas, it'll filter the contents of the library with things pertaining to natural gas. Really anything with that keyword in it. So just to bring up a few layers, here's natural gas pipelines, here's proposed pipelines. When we're talking about some of these shale gas areas, so let's try that layer. And you can, the filters kind of accumulate if you have multiple search terms here, and you can clear those individually or completely with this checkbox at the bottom. You can also just go back in there and uncheck the box here. Just more than one way to do the same thing. Okay, so this library dialog is used to add information to the map. Once you've done that, it appears in what we call the table of contents, and here's where you control other aspects of the map. Now, a couple things aren't immediately obvious when you do this, and that's where those videos can help. One is that you can right-click on these. So if you right-click here and choose Layer Properties, you can adjust the opacity of a layer to make it more transparent. And that's usually more appropriate for solid fills, but I just want you to know that's there. And then sometimes there's multiple styles that you can apply. So this one just has a default style, but as I get in a little farther, you'll see some examples of filtering by different styles. You can also take a layer and drag it to a different position. So the way you do that is you click on the name and drag it to the position. So the higher up it is over here, the higher up it'll be on the map. So if something's obscured, you can just drag it to the top and it'll be on top of the other layers that might have been obscuring it. let's see. There's also this base map toggle at the bottom, so I can change it if I want an image background. I can switch between these base maps or turn them off completely. And the imagery is obviously most interesting and helpful when you're zoomed in close. All right, so let's start with the existing natural gas pipelines, and let's zoom in. So these are symbolized by the diameter of the pipeline, which would really have a lot to do with the volume being transported in that pipeline. So you can see the network of natural gas pipelines, and they might be relevant if you have a power plant that needs to tap into natural gas. Then here's the main network for it. This is commercial data, so this data has been licensed for use in the tool. You'd have to pay a significant amount of money to have it and use it, you know, on your own system. So there's quite a benefit just in that alone in using the website. All right, so in looking at natural gas, I did a little search. I'm not an expert on siting projects. I'm a GIS expert. And I found this article. There's a company that plans to build small plants to generate electricity from gas. And it's in the Marcellus Shale area where there's a lot of fracking going on. And you know, a company wants to use local gas to make electricity that would be sold on the grid and fed back to local utilities. Another thing that came out in the article was that they're talking about pretty small power plants. So they could be sited close to new sources of excess gas. And then I found an example here, Green Township in Pennsylvania, talking about small natural gas power plant. Well, the tool includes models for siting power plants, and natural gas is one of the topics. So when you first log in and use the tool, we've pre-computed all these different models, so you can just look at them. So that's kind of the simplest way to look at one of these. And if I filter on gas, you can see that we have this model, new combined cycle gas turbine. Okay, so this model, and I'll get into modeling pretty soon, so I'm not going to describe how it was made so much as what it's showing. This is essentially a heat map where we've taken a whole slew of siting factors and combined them into a single map and tried to map the areas that would seem to be most suitable for a combined cycle gas turbine type of plant. A significant thing is this is a larger natural gas power plant, in the assumption of the model at least. So in that news article we're talking about smaller power plants, and we've gotten some feedback during some meetings of stakeholders that are pointing out that with the lower cost of natural gas, there's kind of a trend to build smaller natural gas power plants that might be close to communities or you know, sited local to demand centers that would relieve some of the demand for long distance power transmission and would have different siting factors than a large plant like the one in the model here. So with that kind of background, I thought, well, why don't we analyze the potential for small gas power plants in Pennsylvania as a use case. I just want to repeat, you know, in fact, if anybody on the call has some insights about these plants and what a good model or what the issues related to these would be, then feel free to chime in. Again, my background is as a technical person that's helped develop this website, and that's my primary expertise. So that one county, let me turn the counties on. The county that was mentioned in the news article is here. And if we were to just zoom into that area and show the model, I'm going to drag it below some of these layers so we can see it with the other information superimposed. It's a little daunting, so let me right-click on it and make it a little bit more transparent. You can see I don't have a lot of high suitable areas in the county as a whole, but there's a little bit higher suitability in general, right at the kind of the north east part of that county. So let's look at how that model was run. If I go to the Analyze button, I can sort by resource. We've got all these different models listed with different energy resources. So here's natural gas. Here's our new combined cycle gas turbine model. Right? And I can open this up and get a description, and that tells me some of the assumptions that went behind the technology for this particular model. If I click the gear icon, I get the model launcher, which is where I can inspect all the different siting factors that went into it. This was put together by subject matter experts trying to decide what data would be most available and applicable for this type of power plant, and then deciding some default configurations. So you can inspect that, but you can also modify it at will. So just to dig into that, in this case, distance to natural gas pipeline is high. So that's an existing natural gas pipeline, of course, and it's a fairly large one. If I click this gear icon, I can go in and I can see more detailed siting factors for that one layer. So here we're saying if we're within 5 miles of a gas pipeline within at least 12-inch diameter, it's 100% suitable. And the suitability drops off as you get farther and farther away from it. So that means effectively that's going to be the siting factor. It's going to get a stronger influence in the model, and it's going to favor sites that are close to these pipelines. And as you can imagine, all the rest of these characteristics are all combined and weighted in this way. So if I look at land cover area, then I've got a whole series of different land cover types. And if we're thinking about small power plants, we might start raising the suitability of these developed areas. Okay, probably not high intensity, which would be a dense urban environment. Might not be appropriate for, as an ideal site for a power plant. But we might want to just open up the whole this category of land use so that we can just eliminate that as a negative factor. Call it all 100% suitable. Our small power plant won't be dependent on such a large surface water source for its cooling. We might accept higher population densities. So as you can see, I'm kind of thinking about each one of these from the standpoint of a new type of power plant or a different set of constraints. Just so you know, you can also click Add Layers to Model Run, and there's a data library of over 60, I think now reaching close to 70 layers that you can choose from that are all the combined siting factors of all the models. So you can look through there and see, oh, well, I think that would actually be another good siting factor, and refine models. You can even, instead of opening one from default, you can hit Create New Model and build it from scratch. So it's pretty versatile. With that said, I've already run an example test of a small gas power plant with a set of assumptions. And if I look in the results section, you can see some of these say me and some say system. The ones that I've run myself are listed here. And here I can click the gear icon, and you can see the decisions I made for this model. So I've deleted some of the sighting factors, like being near a rail line, and I've adjusted some of the things that I was talking about, and that created a different map. So I've already loaded that in my table of contents, and if I switch to that model, all right, let me make a few adjustments here. County boundaries. Okay. So it didn't really raise the suitability. There may be some other factors that are really coming into play, but it does have a hot spot here. So once you've run these models, then you can start investigating what's happened with them. So what I would do next is start inspecting that area. So what I would do is go to my areas and corridors and click New Analysis Area. And I'm going to sketch a little polygon and try to eliminate this little unsuitable area in it. Looks like that's the urban area. So I double click to finish. And it adds this to the list. Here's the one I just did. Once you show that, okay, first of all, I had them turned off on the map. You need to turn this overlay on, and you'll see it on the map here. I can run a report on this feature. So there are many different reports to choose from. So when I clicked here, it preset the type of region I'm going to analyze on. For example, I can run reports for states or counties or corridors in addition to these little areas that I can draw. And secondly, I can choose from any of these reports. So it only takes a moment to run one of these, and there's quite a few choices. So I'm going to just quickly pick a set of reports and go through them in a group. First thing I would do is run a model result report. And for that, we need to answer one more question, is what model do we want to run it for? Okay, so I'm going to go to my trick is to put a little underscore at the beginning. There's some way to flag it so I can find it quickly in the list. And then I hit Launch Report. And then I'm going to go and run some more. So let's take a look at PowerPoint. And I'm going to run one on protected land. And then I'm going to run one, let's see, let's try habitat. And just for contrast, I'm going to run a power plant report. Well, let me show you how else to run reports. Okay, so that's if you have an analysis area, you want to run a report all about it, you can just call it up straight from here. You can also click the Analyze button, and any of the reports are listed here as well. So if I want to look generally at power plants, here we can say state, and let's run it for the state of Pennsylvania. Okay, so I've queued up a whole bunch of reports, and they appear in the results section. And so I'm going to clear the filter. And a quick way to find the latest thing is just sort by the creation date. You can see this whole slew of reports that are listed now. Here's my test model that I ran. Okay, so the model results report is, again, it's geared to that small area that I digitized. So this tells me, gives me feedback on why that suitability factor was high in that location, which siting factors worked well and which ones didn't. And so these bars, the top bar is the model. In the polygon I digitized, there's completely unsuitable areas all the way to 100% suitable, and the mean is about 90. It's favorable for population distribution, the assumptions I gave it. No troubles with protected land, no troubles with imperiled species. In fact, it's all 100% suitability according to that, and all these other factors. And this is kind of the general distribution of suitability. So most of the area I digitized is highly suitable. And you can see the distribution for each of the siting factors. So obviously, bars over here, 100% would be good for all these different siting factors. And then if you need kind of to document everything about the model, this gives you all the input parameters, the weights and assumptions that went into it, and a short description of the data source. That's kind of a breakdown of the model. So in this case, the model performed very well. In terms of this area being suitable, the siting factors were well behaved and consistent. All right. Let's take a different angle. So protected lands. What's happening in this area with protected lands? First of all, you might have noticed that there were some distances when I launched the tool, and they defaulted to 25 and 50 miles. So everything in this report is presented with three kind of extents. One is the area I drew, and then here's what's happening in the vicinity. So what this does is cycle through a whole bunch of different data layers related to protected lands, the first being the protected areas database. And this is clear, so it didn't find any protected lands in my polygon. It found 31 that were within 25 miles, and you can make a smaller distance, that's pretty far. But here we found that there's Bear Run Nature Preserve within 25 miles. In some cases, that might matter, like if you have a 1-mile buffer in a small analysis area, it might matter if you're near some of these protected areas instead of just in them. And then as I scroll down, National Conservation Easement Database also is clear, doesn't have any issues. Again, that's why it was suitable, but this helps you understand what's going on in that location. And any of these layers, underneath the table there's a link you can click and get more information about the data that the report is based on. And this is the name of the layer in the tool, so I can go add this to the map and show it. So I scroll down, there's national trails. So the Potomac Heritage National Scenic Trail is within 25 miles, but not in my area. And I think you get the idea. Scenic byways. Now the contents of this report vary for different parts of the country. So these aren't the only protected lands layers. These are the ones that are within 50 miles of, that have data within 50 miles of the area I'm analyzing. Okay, I guess while we're on environmental, let's look at the habitat report. That's an even more comprehensive set of data. It actually includes over 70 layers that went into this. So it's cycling through all those different layers and seeing what's close related to habitat. And again, if you go and enter protected lands, there's a composite layer in the tool. And that's kind of a summary of everything related to these. All right, so I'm coming at it from the report. Now I'm going to come at it from the map. Same information. and just to make it visible. Yeah. All right, so in this case, here's our analysis area, and there's a little bit of habitat there that's probably a wetland in the National Wetland Inventory. So the report will screen just about everything that went into this composite view and tell you what's going on there. And for habitat, it didn't find any major issues. All right. Now for power plants, I ran it for the state of Pennsylvania. So this is a different kind of angle here. It's more high-level analysis of the issues. And the buffers around it are not that relevant. So these are a little bit interactive. You can turn these on and off. So within Pennsylvania, this is basically the existing energy portfolio of the state. And you can see coal is the primary source of power in Pennsylvania, and natural gas is pretty strong as the second highest producer. You can get some totals, total operating capacity, and this is again based on that commercial infrastructure data. So interesting, they also have plan data, and you can see that there's considerable amount of new natural gas capacity that's planned for this region. I guess that's not too surprising. So here, I guess that'd be gigawatts of planned capacity in the region, of which natural gas is, over 3,000 megawatts, 3 gigawatts. If you scroll down, there's a lot of detail in this report, so I'm just going to scroll down to the plan section just to illustrate. Okay, so solar, natural gas. Okay, so this is a list of the planned natural gas power plants that are in this data set, and this column is inside the analysis area. So in that little area I drew, there are 4 plants that have been identified. Oh, I'm sorry. No, this is for the whole state. Okay, so there are 4 power plants of this capacity, and here's the county they're planned for in the name. So you can kind of get a sense of what's happening with this report. And then if I go to the one that I ran for the analysis area itself, okay, and I turn off the buffers, there's no power plants within that little polygon. There's nothing planned, but within 10 miles there's a lot of natural gas capacity that's planned. And just like the other report, I can scroll down and find which plants those are in the detail sections. Looks like there's even coal power plants. Oh, these are the ones existing. So yeah, it's primarily a coal and natural gas area. All right. As you can see, the report's open in another tab. You need to have pop-ups enabled for those to work, and you'll see a little flag for that if you have it turned off. That's the way the report's open. Okay, well, one thing that's important to mention is this tool is designed for planning energy zones, and that's not project siting. That's zone planning regions for maybe future development or more strategic planning. So this analysis area is a bit small for that caliber of analysis, but I think it still illustrates the point. So now that I've run a model and I've tried to get a better understanding of why that area is more suitable, obviously as an analyst I would have considered the siting factors very carefully and honed in on those and really tried to maximize what I was getting out of those. And then I've looked at some reports to try to understand the area. Then a lot of times we cycle back to the map and start it. Okay. Let's see, Texas Eastern Transmission, 36 diameter pipeline. Important here is that some of the data sources vary in their quality, so they're saying that this line is within 40 feet of its true position. The natural gas pipeline, can we tell about it? Part of the whole Wayne-Unio system. So that'll mean more to different people that are familiar with some of these systems, or give you some keywords to look up more information. But that's the information I can get on that. And then if I add power plants, let's see. Existing and planned. Okay, these colored dots are existing power plants and planned power plants. The color is what type. So we've got a coal power plant right here. And just as an aside, if you zoom in real close, these layers actually turn off because it's not supposed to get you to that level of analysis, and there were some concerns about sensitivity. Let's back off a little bit. But here's where you might want to switch to the imagery, and then you can actually find and inspect the power plant. So I think it's pretty obvious where that coal power plant is located. Another thing you can do is, so we're really just inspecting data here. Aerial photography will give you a good sense of what's in our analysis area. And that's where we might realize that some of our sighting factors don't get at every aspect of the location. So you can definitely view the imagery and get a sense of not only why it was probably suitable, but maybe some things about it that are happening in that area that aren't addressed in the suitability factors. All right, another way to inspect data is the model layers themselves. So if I look in the library, every modeling layer is in the model layer catalog. And if I take a look here, I can search by title. So for example, land cover. Here's my land cover map, and it gives you a sense of the level of detail in it. If I make it transparent, I can see, here's our developed areas. We called some of those suitable. We also had population density as a factor. So that's probably why that middle area was unsuitable that I went around. And then obviously we've got some forested areas. So you can see the difference between the aerial photograph and the level of resolution. Most of it's forested, but there are some other land cover types that are in there. It's just that the majority land cover type is forest. And that gives you a sense of how those layers came into the model. And if your model didn't give you the results you expected, you can actually inspect this data. Okay, it's ruling out this area. I ranked that too low. I need to raise that suitability factor, and then it'll let me improve my results or make them more focused on what I'm interested in. Okay, so I'd say that's a pretty good indication of what the tool does. The breadth of it is also important because not only do you have models for many different technologies, but you can combine them with what we call a synergy model. So if you wanted to consider multiple technologies, maybe say wind, solar, geothermal, natural gas, you can run models for those four, and then you can combine them together in a synergy model and look for areas that are suitable for each of those technologies simultaneously. So for that you would hit Create New Model and then click Synergy at the lower left and choose the models that you want to combine. Okay, so just as a simple example, if we want to look for areas that are suitable for wind turbines and small natural gas power plants, and we want to weight those equally, so the weights you could weight them according to the actual cost of producing electricity, for example, to give them a more equal basis for comparing between two models. and I can launch that. And I think you can see how we're kind of moving toward finding locations that are suitable for certain types of combinations or individual energy generation technologies. All right, and then that was the results coming on the map. Let's zoom out. Give it a second to catch up here. Okay, so the area I was in wasn't very good for wind, but you can see that certain other regions are simultaneously helpful for both my assumed small natural gas power plant model and wind turbines. So if I wanted to somehow combine those technologies or select regions that were suitable for both of those technologies, I can find them pretty readily with this approach. And then of course I can then digitize an area of interest and dig into it deeper to find quite a bit of data concept. We go back to our region that we're analyzing, and let me add transmission lines. Okay, let's turn the analysis area back on. I'm going to zoom in. And we're actually pretty close to a transmission line already. Let me add substations. You've got to connect somewhere. Okay, so here's existing substations. And this is one of the layers, transmission lines, where I can actually go on the properties, and there's different styles. So I'm going to just say by category, because there are some lower capacities that are not turned on by default. So just as a very simple example, if I wanted to get a sense of what's a potential way to connect in, and again, this is more of a regional planning tool rather than an individual transmission line. I've got to zoom out enough for my infrastructure layers to be on. Then I can digitize a corridor. So we don't know much about this area at this level, so let me just draw a line and say we want to connect to this substation as an example. And let's just have a wide screen because we don't know a lot. We want to screen for issues. So let's say it's 2,000 feet wide. Transmission line right away is not going to be that wide, but if we're just trying to look for alternatives, we want to have a broad brush. I've got a lot of these, so I had to give them more specific. Okay, so for this we have a corridor report. So what you would do, it's already picked my corridor, and I picked the corridor report and launch it. So it's drawn not only the center line I drew, but that width around it. And what we're doing now is we're seeing what's going on in that swath that has to do with siting corridors. And if I sort, okay, it's ready. So first of all, some locational information. We find out that the first 2.5 miles are in Greene County, and then it transitions to Fayette County. And then it's near these populated places or goes through them. So that might not be that helpful if I'm going straight through populated place. Population is low density. Then we have a series of profiles, topographic profile. We can inspect those and see if there's any really steep slopes that we want to avoid. Our maximum slopes, they're pretty steep, so it looks like I've gone over some ridges or something. We're intersecting State Highway 88. Here's a series of transmission lines that we're touching or intersecting, mostly at the end, which is where you wouldn't be surprised because that's where we're trying to connect into. Here's our substation that we ran into. Sometimes you have to consider pipelines around transmission line because the magnetic fields generated around them can, make the corrosion on pipelines accelerate. So you need to take that into account in your engineering design. There's 3 airports, so if we're building transmission towers, we should be aware of those. Mainly for pipelines, we might be concerned about the seismicity of the area. So there's data about that from the USGS. And then at the bottom is a summary of protected lands, habitat, and imperiled species data. So we found in our first milepost we have some areas, not very much, but part of our area has some habitat issues. So again, here's where you would look at the name and you can add that layer to the map and start inspecting it. But that's an awful lot of information to try to put on your map and understand compared to just having this report tell you what's going on there. So one of the things that we're doing this year is not only having a descriptive tool where you sketch a corridor and find out what's in it, but you use the siting factor approach like the model that I showed you. You develop a surface that represents suitability for a corridor. So siting factors. It could be something like follow existing transmission lines as one of my alternatives. And for that, you'll be able to digitize just the endpoints, and it'll generate a route for you that tries to find the most suitable path based on your assumptions. So that'll be the topic of the webinar next week. Next month. Some of that hasn't been released in the tool yet, so we may be showing you some things on our staging system. It's just if you need to get that pushed out soon, it may be on the website by then, or it might be a staging demonstration. But in the near future, you'll be able to generate corridor routes as I just described. All right, and then if we, just to go back to what's going on there, and I've got some of those layers in my okay, so it was habitat that had some concerns. So then we could run a habitat report on that corridor and find out what that is. So this is just a general sensitivity factor, but it doesn't tell me what that is. So again, it kind of goes circular. We're running models, running reports, and inspecting data. You go back and forth between those. So here I'm going to find the habitat report. I guess I could sort others. And then what was it? This one. So the corridor report just gave me a simple, brief summary, along the mileposts of that, kind of giving me suitability factors. And then this will tell me what's going on there. So if I scroll through, okay, okay, Live Easy. Core Habitat Pennsylvania data set, and there's also that's temporary polygon. That looks like kind of crude data, but the point is then we can go back to our data library. I'll just filter on that state abbreviation. And for habitat. Okay, so there's my source data, and if so not all of that is in my siting area, and I can click on it and look up some details about it. So it gets a little deep in the weeds, but if you're really citing projects, this gives you kind of the initial screening factors that you might want to consider as you start planning a corridor or analysis area. Right on the base map, you can see I went square through an airport. That was just accidental. So if I wanted to adjust my corridor, then I can go in here and pick, copy it, oh come on, something went wrong. All right, so I was trying to copy it and adjust it, and if I do copy again, oh, I'm sorry, I had the wrong one picked. Point is, if it was a code here, it's letting me adjust my analysis area and change the boundary. So I must have misclicked the wrong one there. I can save that, and I just clicked on the wrong thing that I was trying to edit there. Kind of dumb. That's where you want to maybe put some more descriptive names as you're going. So with that, I pretty much consumed an hour here, and hope it was helpful and informative for you, that you find the tool helpful. Some of the interface that I was showing you has already been improved in the stuff that we're going to push out. And specifically, being able to copy and adjust these has been made a little bit more intuitive than that button that's buried into the rename tool. And then we'll have new corridor tools that let you do automatic routing of corridors. And we're also updating the tool with climate change and other water-related data that have to do with energy production. So those are some other activities happening this year. And I just want to give you a final chance to ask any questions, and thank you for participating. So if you have any questions, just speak up or use the chat, and I'll stay on the line for a few minutes or until there aren't any more questions. With that, thank you for your time and interest today, and I hope you find the tool useful.